Okay, in this video, this is part 2 in a two-part series on image processing in C#. In part 1, we talked about some basic understanding of images and how they're configured in the computer, and stuff like bits per pixel and colors and RGB and alpha. And it's really important that you understand those basics before you get into image processing in C#. Otherwise, it'll be kind of confusing. So I strongly suggest you take a look at that if you're not already very familiar with images. Now, in previous videos in these series, events and delegates and threading, we've been working on an application that is using an image manipulation application. And we use that to process an image. It takes a few seconds to process, and that helped us understand about threading and how you can free up your user interface when you're doing some CPU intensive image processing, and also how events are generated after the processing is done, and delegates. And so again, I suggest you take a look at those to get some background on what we're working on here. In this video, we're going to kind of extend that application we use for image processing and introduce another method that is much faster at image processing than what we were using, and that's called LockBits. And we'll show how you can vastly speed up that application, and maybe you don't even need the threads that we generated in the threading video. So first thing I want to talk about is that application. It's basically, if you saw the other videos, it's basically got three parts. You got the standard Windows form application, which has the picture boxes and the buttons. We've got a separate class it's called a file operations class, and that, we make a request to do an open file dialog. We pull in an image, convert it to a bitmap, and that's what the file operations class does. Then we take that bitmap and send it out to what's called the image manipulation class. And that's the class that has a method that does the hard work. It takes the bitmap, goes through every single pixel in the bitmap, changes the color, changes the RGB values we talked about in the last video, and saves that out and issues a notification to any subscribers to the event that says, hey, the image is finished processing. It took 3 or 4 seconds, but it's done now, and you can go grab it and you can display it on the picture box in the user interface. And along with that, we had this image manipulation class running on a separate thread from this user interface, so that it could be off for 3 or 4 seconds doing this without affecting this Windows Forms. So that's the basic design. What we're going to do here is going to take this image manipulation class and modify the method that we're using to change the colors of all these pixels. So instead of 3 or 4 seconds, it goes a lot faster. So let's jump into Visual Studio, and here we have the basic code for the Windows Forms user interface. And you can see we've also got the file operations class and the image manipulation class. Okay, so the basic forms hasn't changed from the previous videos. We've got the code to do some event handling. We've got a event handler to display the bitmap on the picture boxes. We've got the button to open the file, the click event handler to get the file and display it. We won't be changing that. And here we've got the event handler. When we click the button to manipulate the image, this is what calls that manipulate method down here in the separate image manipulation class. It calls that manipulate method and passes this new file. And this is the code that starts a separate thread to do that manipulation, so that's separate from the user interface. And we talked about that in the thread video. So it's very simple. We're just calling the manipulate, starting it on a new thread. Here we've just got a event handler to display the image when the image is finished. and an exit. Here is the one change I've made in this user interface code, and I've added a separate button which calls a separate method that uses this new LockBits method that's much faster. And it's identical to the call to the old method, manipulate. Instead, we're calling manipulate 1, which is the new LockBits method. And it uses exactly the same code to start a new thread, but instead it calls manipulate 1, but passes new file the same as this. So really, there's no change to this main user interface code except to add a separate button that will run the separate code. Now, let's show you this updated application. I've made some changes, and basically I open an image. Let's pick the image. It opens and displays it in both text boxes. Now, in the old method, used what's called setPixel, and we'll talk about that. But basically, I'll click on this, and you can see that it's going to take a long time. The method will go through every pixel, get rid of the blue in all of the RGB of every pixel here, and when it's done, it will display it here in this picture box. So I click Set Pixel, you wait, you wait, you wait, you wait, and finally it's done and it displays the updated image. Okay, so because that took so long, 3 or 4 seconds, we had to run that code that did that manipulation on a separate thread. Now, let's try it again, but use this new LockBits method. Okay, so I'm going to click on LockBits, boom, it's done. So you can see it's almost instantaneous, or in fact it's pretty much instantaneous compared to the old method. So that's what we're going to show, the difference between those two methods, the manipulate method and manipulate 1. So let's jump over to the image manipulate class and go through what we've got here. And basically, we've got from the events and delegates, we've got the image event args, which just says we're passing the bitmap. That's in the events and delegates videos. You can check that out. Here's the main class that does the image manipulation. We've got some code for the event handler. Here is some code when the image is finished. It passes the bitmap out to through the delegates to the subscribers. This just invokes the event. And then here is the core of the code, the method, the old method that we use to manipulate the object. And basically, this is the one that takes 3 or 4 seconds to complete. Basically, it takes a bitmap as input. And because we were using threading, we took an object, not a bitmap. And then the first line of code, we cast that object to a bitmap. So BMAP is the bitmap we're going to work on in this code. So here we're just defining we're instantiating a new color object so we can set the color of each pixel to this value. And here we just got a couple for loops that go through from 0 to the width of the image and from 0 to the height of the image. They go through every single pixel in the image, and they get the color of the pixel at this location, ij, and pass it to the color, which is our new color that defines the RGB values of that pixel. So we get it, we modify in this line of code. Basically, we're saying the color, the R value of the color, the green value of the color, and the blue value. But we're saying the blue value is now 0. So we're taking the existing R, the existing G, and changing the blue to 0. So we're zeroing out the blue and just passing through the R and the G, and we're sending that to a new color, from the color to a new color. So we're making the change here, and then here we're setting each pixel to that new color. So the new color is now red, green plus 0, the old red, the old green, and 0, and we're passing that to each pixel using setPixel. So now the bitmap, when we're all done, this bitmap will have all these newly colored pixels without the blue. They'll all look kind of yellowy. So the problem is get pixel and set pixel have a lot of overhead that takes a lot of time. Basically, I think you're going into each pixel and you are locking the pixel so you can access it. You're making a change and then you're unlocking it. And that code, that overhead, doing that on every pixel takes a whole lot of time. So what we're going to do is we're going to look at another method so that it goes, that get pixel and set pixel aren't used anymore. We do something that operates on a fully locked bitmap, okay? So basically the bitmap gets modified and we call the method to send out this modified bitmap to the subscribers. In this case, they're just one subscriber, the user interface. So it passes the bitmap via the event that we generated in the events and delegates, and therefore the user interface can take this new bitmap and update the picture box. So here's the old method that took it 3 or 4 seconds, and now we're going to look at a new method that is much, much faster. And we'll step through this so you can understand how it's very similar but done a little bit differently. So the new method is called manipulate one, and again we can select this based on those 2 buttons in the form. And again, we, just like the other one, we pass it an object bitmap, then cast it to a bitmap. So now again we're working on the same thing. BMAP is the bitmap we're going to be working on in here, and here's the code that modifies it. Now the first thing we need to do we need to identify this code in these brackets as unsafe. Now, why do we need unsafe? Well, unlike C and C++, C# doesn't support pointer arithmetic by default. Okay, C and C++, you could use pointer arithmetic, but not in C#. So what you have to do is you have to say, okay, this is unsafe code, and you have to accept in the compiler that you're willing to accept unsafe code. To do that, you do the unsafe in the brackets, but you have to tell the compiler. So you select the project, you right click, you go down to properties, and here under build there is a checkbox that says allow unsafe code. Make sure that is checked, and if it is, then you won't get a squiggly under the unsafe. Otherwise, unsafe will have a squiggly. So the first thing is you define your code as unsafe. The next thing you do is you take this bmap, this bitmap image that you want to manipulate, and effectively what this code is doing here is it is taking that entire bitmap and is locking that bitmap into code and allowing you to access each pixel very fast using pointers. Okay? So bmap.LockBits applies the LockBits method to this bitmap, and we are saying to LockBits, okay, here are the parameters of the image that we want you to lock. Okay? And one parameter is we are defining a rectangle, a new rectangle object that is defined between 0 and the width and height, basically setting a rectangle around the width and height of the image of the bitmap. Okay, so this defines the dimensions of the area to be locked, and this defines the mode. We're saying for that area, lock it and give us read-write access to that area using the image lock mode. And we're also feeding the information that bitmap has this pixel format. Now, what is pixel format? Well, if you looked at the part 1, we talked about RGB definitions of each pixel. And that's the red, green, blue. And we said if it's 8 bits per pixel of red and 8 of green and 8 of blue, that's a 24-bit per pixel image. So the pixel format just tells you, for example, the definition, the name of the correct pixel format for 24-bit is format 24 BPP, or bits per pixel RGB. So this image we're bringing in, we know, have 24 bits per pixel RGB. Okay, that's pixel format. Now, as we said, if you have alpha or transparency, an additional 8 bits, it would be format 32 bits per pixel alpha RGB, which is this A. So when you see A RGB, it means alpha or transparency RGB. So now we're just saying, okay, LockBits, lock this area defined by the dimensions of the image, give us read-write access, and the pixel format is 24 bits per pixel RGB, okay? So we're defining the area we're going to work on, okay? Now the next thing is we just define some variables, all right, just to make our life easier. And here we define the number of bytes per pixel. Now we know it's 24 bits per pixel, so how many bytes? Well, 24 bits per pixel divided by 8 bits per byte gives you 3. So this is going to be bytes per pixel, which is basically getting that 24 bits per pixel number and dividing by 8, okay? So that's all you're doing. You're getting the number of bytes per pixel. And then we're getting the height in pixels, which is the bitmap data. Remember, we converted this to a variable called bitmap data that's got all the characteristics of this locked area. So the width times byte per pixel, so it's the width in bytes. Okay, so we're going to use these variables in our code. Now, the first thing we do, since we're working with pointers to this this area that we've locked, the first thing we do is we define a pointer to the first pixel in the array. Okay, to do that, we use the scan zero property or method of the bitmap data, the definition of the array of data. That returns that gets or sets, it's a property that gets or sets the address of the first pixel in the bitmap. Okay, so it's the pointer to the first pixel in the bitmap. So this code just tells you how to go to the first pixel in the bitmap. All right. So now we're all set to go through and actually do the getting and setting just like we did before. But in this case, we're going to step through the image using what's called a parallel .for. Okay? That basically executes a for loop on what's in this parentheses. We got a parentheses here and a parentheses here. So all of this code gets executed in a for loop that goes from 0 to the height of the pixels, and here's the code it gets. Okay? So the first thing it does, it is basically going through this line by line of the image. Okay, so you're defining one line of data and operating on that, then stepping down to the next line, operating on that, and so on, all the way to the total height of the pixels in pixels of the array. Okay, so this line of code uses the stride property of bitmap data. And you can see bitmap data has a lot of information that you can access. It's got the stride, it's got the scan zero. So basically, you are defining the first line as current line of data by the location of the first element, and you're defining that line using the stride or scan line width property to define the line. And then you are stepping through for each line from 0 all the way to the width. You're going through each pixel in that first line, and here you're going to get, just like we did before, get and set. Here you're going to get each pixel color, R, G, and B, and to do that, you grab the R, G, and B, which are from 0 to 255, remember. You're going to grab the old blue, or the existing blue value, which is current line at the X location. Green is X plus 1, and red is X plus 2. So here you're just grabbing the blue, green, and red values and feeding them into these integer values of old blue, old green, and old red. Okay? Now this next set of code is the set. You're basically going to zero out those values in the current line blue, green, and red values. So Here I'm setting the blue value to 0, and I am setting the green to what it was before, the old green, and the red to what it was before. So I'm just copying through the old values of green and red and zeroing out the blue. So basically, this code is going to do exactly the same as the other code, but as we saw, it's going to do it a whole lot faster. So hopefully you can see, you go through, you do all your parallel for loops that basically can do these iterations in parallel. And it will do that very fast, plus the fact that you're using these LockBits, and you're addressing it, you're locating the pixels, you're modifying the pixels by address. All of that goes together to make this extremely fast. So once that's done, just like this other method, we call onImageFinish, the method that will pass through the finished bitmap. So it's been changed, and it will initiate the event handler and fire off an event to call the event handler in our main application so it can grab this finished one, and that's what updates that picture box so quickly. So hopefully you now get a better feel for some ways that you can really speed up your image processing using this LockBits and also this parallel for to do a for loop in parallel. So hope this helps, and I encourage you to look through some of the other videos to help explain some of the other things we're doing in here. So take care and have a really good day.